Same time.
Good afternoon. So 12-factor apps. See, does this work? Yeah, sometimes it does. So 12-factor apps. In our industry, we seem to have a love affair with TLAs, or three-letter acronyms. It doesn't matter if they're already used, we'll use them again. So what's 12-factor? Most of this is probably common sense, or will be common sense at some stage. It was created from experiences viewing software as a service in the wild by Heroku, by a guy, Adam Wiggins. He was one of the co-founders in Heroku. It can be viewed kind of as a summary of ideal practices for app development, with an emphasis on allowing organic growth over time. It was also hoped to raise awareness of some of the problems they'd seen, and to provide a shared vocabulary and terminology to discuss those problems. So the 12-factor app, it kind of gives us the ability to create applications that are scalable, maintainable, and portable. So we've seen loads of these IaaS things, like software as a service, e.g. Office 365, platform as a service like Heroku, Cloud Foundry, infrastructure as a service. You have AWS EC2, you have GCE, Microsoft as you have backend as a service, container as a service, function as a service, for example, AWS Lambda, Google Cloud Function, Azure Functions, data as a service, and then there's XaaS, which is something as a service, or covers everything else. We could be creating a product that's going to be delivered as a SaaS solution. For that, we could be using a PaaS solution to develop it and deploy it, and that their SaaS solution could be using an IaaS solution that actually hosts it. Another term that's thrown around quite a lot is cloud native. So in general usage, cloud native, it's an approach to building and running applications that exploits the advantages of the cloud computing delivery model. It emphasizes on how applications are created, not how they're created and deployed, rather than not where. It implies that the apps live in the cloud as opposed to your on-premise data center. Now, the CNCF, the Cloud Native Computing Foundation, has its own definition. I'm not going to read all this out for you. Feel free. It's on their website. But the CNCF serves as the vendor-neutral home for many of the fastest growing technologies on GitHub, including Kubernetes, Prometheus, and Envoy. So it's to try and foster collaboration between the big players and the industry's top developers, the end users, and get them all working together. So some random dates and milestones that I find interesting. So Rackspace was launched in 1998. There was hundreds of IT hosting companies at that time providing access to kind of single tenant hosting services over the internet. Their customer service tended to be quite bad. So what Rackspace done is they focused on customer service, and they went from being a very, very small player to being a major player quite quickly. They got involved with NASA in, I think, 2010, and they launched OpenStack along with 25 other partners. So it was Rackspace and NASA were the two main players behind OpenStack. VMware was another one. It was founded in '98. It was operated in stealth mode for a year and officially launched in 1999. VMware, along with other hypervisors, kind of led to this whole cloud paradigm that we have now, or enabled it. We have EC2, which was Amazon's elastic compute cloud. It came out around in 2006, and it's viewed as a game changer. Heroku was one of the first platform as a service offerings in 2007. It was Adam Wiggins, that's one of the co-founders, that actually published the 12-factor app. You have the Google App Engine, again 2008, and it came out of preview in 2011. It's Google's platform as a service offering. You have Azure. So there was Project Red Dog, was started by Microsoft in 2008. They officially launched it as Windows Azure in 2010 and rebranded in 2014 to Microsoft Azure. You have Cloud Foundry, which came about in 2009. It was actually designed and developed by people, a small team within VMware, and it was released in 2011. The Cloud Foundry Foundation was created in 2015 as an independent, not-for-profit Linux Foundation collaborative project. So there's 7 certified Cloud Foundry platforms at the moment. And you have GCE, which is the Google Compute Engine. It's the IaaS component of Google Cloud Platform. So it was announced in 2012 and made available in 2013. We have Docker, which came around in 2006 years old this year. You have Kubernetes, which actually turned 5 years old yesterday. In the world of things, it doesn't sound like that long, but Kubernetes came around and changed everything. And then we have serverless. AWS Lambda, I think, was announced in 2014. You have Google Functions and Azure Functions as well are available, as well as some others. So kind of, as I mentioned, you had Adam Wiggins. He was one of the co-founders of Heroku in 2007. So they saw a lot of the problems that software as a service was experiencing. So what they did is, viewing that, they came up with this idea of a 12-factor app. It was kind of created from their experiences and observations, and they've made it available both on the website and as a downloadable ebook. It has been compared to the Joel test, 12 Steps to Better Code, which was, I think, about the year 2000 it came about, and the format was inspired by Martin Fowler's books. So the Joel test, for anybody that hasn't seen it, it used to be a huge thing, but now it's almost a comical thing at this stage, because it's very difficult not to do some of these. Like, do you use source control? Like, who doesn't anymore? Do you make a build in one step? We have CI/CD all over the place. Daily builds, yes, we make hourly builds, minute builds. Do we have a bug database? Do we fix bugs? Yeah. Do we have an up-to-date? Do we have a spec? Well, then now it's a case of, do we have a user story, or do we have a value proposition or something like that? You know, all these things are taken for granted now.
My working conditions are not taken for granted.
Sometimes.
That's why phones are worth so much these days.
Noise cancelling headphones do a great job. But like, they all look a little bit crazy now, but at the time and over the years, like these were something you strive for. So we'll jump straight into it. The first one is code base. So according to the 12-factor app, you should have one code base tracked in version control with many different deploys. So you have a single code base, and a deploy is anywhere that code base is. So you may have a code base on production, one on staging, and any developer that has a copy of that code running locally is also a deploy. So if there are multiple code bases, it's not an app, it's actually a distributed system. Now, a distributed system can be comprised of multiple different applications, and each of those applications can by itself be 12-factor compliant. If there's when you have multiple deploys of the app, so when you look at production, if you look at your local environment, the developer, you have commits there that aren't yet in staging. If you look at staging, staging has commits that aren't yet in production, but they all still have the same code base. Let me see. Yes, so yes, there shouldn't be any shared code, so you shouldn't be pulling code in and shared among different applications as well. The way around that is you would factor it or refactor it out into its own library and include it as a dependency for that application. Moving on into our dependencies. So the dependencies should always be isolated from each other and explicitly declared. A 12-factor app never relies on the existence of any system-wide dependencies or anything on the underlying system. For example, curl, wget, or something like that. You always explicitly declare them, and they will get installed as part of it. Libraries can be installed system-wide as site packages or scoped to the app, known as vendoring or bundling. Also, you want dependency isolation to make sure that nothing from the underlying system leaks into the application itself. So, for example, a Java Spring app does this quite well. It's something that they got fairly good. When you do it, it creates a jar file that includes all the dependencies and the built asset and everything else all in a single thing. .NET isn't quite there yet, but with .NET Core and ASP.NET 5 and the SCD, the self-contained deployment, it doesn't rely on any underlying shared components on the target system. So it's getting there. It's very, very close now. Some would argue it is there already, but it is getting there. One benefit of this dependency isolation and dependency declaration is if you have somebody new comes onto your team or drops on or whatever else, they just grab the code, run the install command, and they're up and running. There's nothing else needs to be done. You don't have to spend a week building your machine in a specific way with specific stuff on it just so you can get the application to run. Storing the config in the environment. This one rattles a lot of people's cages. For a 12-factor app, the config is, sorry, Wi-Fi is acting up here for me, naturally. For the 12-factor app, config is anything that's likely to change between deployments. So you will have your code base, and then you'll have a specific configuration for production, staging, your local environment. An example might be databases. So you have a production database, a staging database, a local development database. So the litmus test for that, according to the document, is can you release your code at any particular point in time without leaking out any credentials? The definition doesn't include any internal configuration, let's say between modules inside the code base or routing or anything along those lines. You can have, let's say, route mapping or internal configuration. That's not included, it's just external configuration. A traditional approach to this was having your configuration as constants in your code. An improvement in that was that you had various different configuration files for different environments. So you might have a configuration file for your staging environment, for your production environment, for your local environment. They weren't supposed to go into the code base. Quite often they're included and checked into the code as well. For the 12-factor app, it states that you have to have them as environment variables. There are ways around this now that you have cloud configuration services that allow you to do it. But the crux of it is your code base and your configuration are two completely separate things. You do not have your config in your code base. Moving on to backing services. So we want to treat our backing services as attached resources. Any service the app consumes over the network as part of its normal operation is a backend service. So it could be a database, it could be a message queuing system, it could be an SMTP service for email, it could be a caching system, or it could be a third-party API or anything like that there. They're all attached resources and they're treated that way. The code should make no distinction between local backing services or third-party services to the application. They're both just attached resources accessed via a URL. Each backing service is a single resource. So let's say a MySQL database is a single backing service. If you're using two MySQL databases for sharding or something like that, that's two attached resources. The resources can be attached or detached at any point in time without you having to change the code. So an example would be, let's say your database isn't behaving correctly, the DBA decides, okay, I'm going to kill that, takes it back up, spins up a new database instance, it has a new URL, passes on to you, you change it in the configuration, you may have to reboot your app, but you're good to go again. You didn't have to do a new code deployment, there's no code changes required. These days it's kind of the concept of mobile first is getting there, but when we move on to this, we get to the idea of API first, and it ties into this as well. So you'll notice these all kind of relate to each other and naturally progress on. So we want to separate the build, release and run stages. The 12-factor app uses strict separation between each of these stages. So for the build stage, what we do is it just gets the code, takes it from the repo, transforms into some kind of a built asset. It includes all the dependencies, compilation if it's needed as well. So you take it, you have a CI pipeline or something like that. It could be Jenkins, Travis, Circle CI, whatever it may be. When you run it, it actually goes, grabs the code, reads the manifest for the dependencies, pulls them all in, runs the compilation, runs the build, and you have your build. The release stage then goes and it takes the built asset, it gets the configuration for the environment that it's looking to run on, and it actually goes, puts them together and creates a release. So the release is ready for immediate execution in whatever environment it's for. The run stage, which isn't shown here, takes that release and it actually executes it on an environment by launching some set of the app's processes against it. So the deployment tools typically offer some kind of release management that will include the ability to roll back. So every release is given a unique release ID, for example, a timestamp or an incremental version number. Releases are an append-only ledger, so it's an immutable entity. So once you create a release, it's there, it's done. If you need to fix something or do something else, you create a new release after that. So it ties into the idea of a blue-green deploy or a red-black deploy or this kind of continuous deployment model or zero downtime model. Processes. So on a 12-factor app, we execute the app as one or more stateless processes. The app itself does share nothing. It contains no state and it shares nothing between processes. If it needs to store anything, it uses an external stateful service that is attached as a backend service. So for example, a database for session store. It is not stored within the process itself or the application itself. The memory space could be used temporarily. Let's say you're downloading a large file that's going to be processed and it's going to go into a database. Then you could temporarily use the cache within the process or within the app for that, but you don't store anything between them. Even if you're only running one process, you still want to adhere to that, because at any point in time that process could be killed and another one spun up or could be restarted. Some older web systems used to use this concept of sticky sessions, which actually break the 12-factor methodology. If you're looking to store some kind of session state, you want to be looking at an external way of doing it, let's say a memcache or a Redis store or something like that. So port binding. Again, we export the services via port binding. So instead of traditional way of doing it, we have let's say an IaaS server, an Apache server, or some web server, and we install our application on it, and there you go, you get a URL and all this. So when we move to 12-factor, we don't rely on the injection of a web server into the execution environment to create it. So the app itself exports the HTTP service by binding it to a port and actually listening on that port for all incoming requests. So typically it's implemented by a dependency declaration to add a web server into our application when it's been built. The port is provided by the environment that's fed into the app, and then using the start command, it listens on that for requests. The applications are fully self-contained, and this allows one application to become the backend service for another application. So if I'm doing a backend service that connects to a database, well then I can export that via port binding. That means, let's say you're doing a consuming application for that, then you're able to develop alongside me, and you're using a different port, we're all able to work together. This ties nicely into the scaling as well and load balancing, which we move on to concurrency. So with the processes, this allows us to scale out via the process model. So if we look at it, the 12-factor app processes are a first-class citizen. They take very strong cues from the Unix model. So developers can architect their application to actually have different types of processes and assigning different work to different process types. So for example, we might have HTTP requests. They're quite light, they're quite quick. We only need 2 processes to take care of those. There may be some backing services or back-end tasks that take a little bit longer to do. So what we do is we spin those up, and we may have 4 processes to actually take care of the back-end tasks. So this doesn't stop each process from actually managing its internal multiplexing. So like it might be doing threading, or it might be doing some kind of event management within the process itself. This really shines when we start scaling out. So because we're having processes that share nothing amongst each other, we can scale out horizontally very, very easily. The traditional way was we need a bigger server, we need more memory, we need more hard disk space, we need more CPU. This way we don't, we just spin off and we just have another node, another pod, and another instance of the app, and it all works. So the other thing is 12-factor apps don't manage their processes. They rely on the underlying system, so they delegate that out to the operating system or whatever else to take care of it, because that's actually what they're better at. So, disposability. So in order for this to work, we need to maximise the robustness with very, very fast startup and graceful shutdown. So this isn't going to work if our application takes, half a minute or a minute to start up every time we need to go there. It needs to actually spin up very, very quick. Likewise, it needs to be able to spin itself down very quick. So if we send it a termination signal or SIG-term, it actually completes the request that it's doing, kills itself, and all new requests go to whatever the new process that got spun up. So we strive to have our application spin up as quickly as possible, and we also need to plan for when bad things happen. So we need to take into account, let's say there's a hardware fault or there's a completely unexpected failure. So as long as you're adhering to the other factors, let's say a message queue, you're consuming a message queue, the message doesn't actually get completely deleted off the queue until the process is finished. So if there is an unexpected failure, that message gets picked up by a process later on. If we look at a function as a service, it's very, very fast. Usually they come up in maybe 125 to 250 milliseconds. So when we're starting to look at that kind of speed of spinning up different processes and applications, along with scaling out via the process model, this enables us to be very scalable very easily. Dev prod parity. Traditionally, this was an area where we were really, really bad. So you may have had, in production, you might have been using an Oracle or an MS SQL database or a Postgres database or something like that. And there was huge licensing issues and cost and everything else. And you couldn't run them in local environments anyways. So you may have had a SQLite database or something like that on your local development environment. So the time between deploys was typically weeks, sometimes months. So you do your work, do whatever else, testing came in at the end and it got cut because everything didn't get in correctly. And then you had your big deploy weekend or your big deploy day where everybody was on call and there was 200 apps going out and everybody was crapping themselves in case this would or would not work. With the 12-factor app, what we're actually looking at is hours. So you may deploy a new version every couple of hours, but that's because you have CA, you have CD, you have tests built in, you have automated, so you're adhering to all the other best practices. So you're reducing your time as much as possible, so you want to reduce that gap. The other is the code authors versus the deployers. In your traditional one, I write the code, it's all working okay for me. I'll write up a document, pass that on to the ops people for the deploy weekend, and they'll try and read my mind and figure out what was in the document to actually make the application work in the environment that is nothing like the environment that it was actually developed on. Whereas with 12-factor app, we take care of the CI/CD pipeline, we're actually involved in it, and we can make it work, and it's happening that often that problems, when they do crop up, they're not big ones. And the dev versus production environments. I touched on this earlier. With traditional, they were very, very different, whereas once you get into the 12-factor app, they're as similar as possible. There's quite a few of the big players now actually offer light versions of their own production tools or their own production offerings that you can run in the development environment. When we get into containers and Docker, Kubernetes, we can run an awful lot of those things locally as well, so we don't have to have divergent environments. Logs. So we want to treat the event logs as streams. So all the logs are is just events. We no longer look at or care where we're putting these there. We're not putting logs into a file. All we're doing is we're just dumping the logs out to standard out, standard error. Now, we're taking it, there's an agent there someplace, and it's going to just scoop all them up, take care of them, put them wherever they need to be, and that's it, job done. So if we're doing it locally, those logs will get dumped out to our terminal. Maybe we want to debug. In production, they may be getting scooped up, put into Splunk. You might be using something like the Elk stack, so Elasticsearch, Logstash, Kibana. There might be Splunk. There'll be some way of actually looking at the logs and analysing them and getting some kind of data out of them. It also ties nicely in against with the security end of things. So it lines up with the CAA, the confidentiality, integrity, and availability. And logging is actually number 10 in the WAS top 10 list since 2017, so it is a fairly big one. Admin processes. This is one I'm not too sure. I think it was bigger. So admin processes should be one-off processes. So you may have a scripts directory within your code base. They're not part of your application code, but they are part of your code base. So for example, if you're doing a database migration, you may have the script for that database migration as part of your code base, but it doesn't get ran as part of your code, part of your app. It could be ran by a SSH and into a node or whatever it is and run it ad hoc, or it could be run through a CI pipeline. So after the 12 factors, you have Pivotal published a book, Kevin Hoffman. He published a book, I think in 2016, PaaS the 12 factors. So he reordered 12 factors and added another 3 into it. One was API first, which we all hear of every day. When we're doing something now, we do an API first, and that means anybody wants to consume it can consume it. The other is telemetry. So we want to be able to monitor the application. We want to be able to have different categories of data about the monitoring and authentication and authorization. So we want to make sure that security is built in from the start. It's a vital part of the application and the cloud environment. So we want to make sure it's never an afterthought, that it's actually baked in from the very, very start. So coming back to our lovely 3-letter acronyms again. Why 12-factor? Well, the main thing with 12-factor is the constraints that it puts upon us allows us to create applications that are very, very scalable, very maintainable, and very portable. The agility and being able to respond actually allows us to scale well. So just give a bit of background. Overstock is a company I work for in Sligo. They're part of overstock.com, which is a US-based e-commerce retailer. So for us, we need to be able to scale for Black Friday, for ups and downs as much as things need to be. Thank you very much for your time.